In this video, we're going to make trace noise measurements on FieldFox to see if we can verify the performance of the trace noise of the analyzer. If you look at the specification document for FieldFox, there's a trace noise spec of about 0.04 dB magnitude, 0.07 degrees phase for frequencies less than 20 gigahertz. So we'll take a look at that value. To do that, we would come and look in network analyzer mode. And I'm going to switch it to S21. This is from preset. And I have a direct cable connected between my two ports, a direct connection. You can kind of see that's the loss. As we get higher frequency, higher loss. I'm going to test at 10 gigahertz. So I'm going to change the frequency to 10 gigahertz. You can test at different frequencies, spot check at various frequencies. And then we do a span of 0. Here we say it's high power and 300 hertz I have bandwidth. So but I can see my power is minus 15. So I change my power to high. And I need to change my bandwidth to 300 hertz. So now I have the measurement settings that I need. So then I'll do a normalization. You can do a response cal or you can do data over memory, either way, because we really want to look at the noise. And now I do an auto scale just to make sure it looks about right, and it does. But this is a measurement, it's a standard deviation measurement, and to do that we really can't take standard deviation of a log mag. We need to take it in linear. So I switched it out into linear. You still can do an auto scale to see if you want to see the data. And then I will go ahead and save this data on a USB stick in CSV format. So I'll save this, and I will call this trace noise 10 gig mag. At the same time, I'd like to measure phase, so I'll go ahead and change it to phase. And again, trace, math memory, data to memory. And you want to look at data over memory, and here it would say data over memory. I can do an auto scale to see kind of the performance if you want. The reference is 0. It really should be centered around 0. Oh, and it's important that the instrument has been on for at least 2 hours, so it's completely stable when you're making this measurement. Now let's go ahead again and save this data, and we will call this trace noise phase 10 gigahertz. You can make this measurement at different frequencies too. Let's do it in the 20 to 26.5 gigahertz range. Let's do it at 22 gigahertz. Again, at each frequency, you want to make sure you do the data over memory. And now I'm going to save this, and I will call this one 22 gigahertz phase. And let's take a look at magnitude also in linear format. Data over data to memory. I'm going to save this as clear at 22 gigahertz mag. And it's linear, just so we can remember. Now I'm going to take this data and bring it over to my computer, and you could either FTP it or I just saved it on a USB stick. And I will open my Explorer, and let me bring this over here. We'll go over to my, where's my, plug in my USB stick again. Is my computer seeing it? Desktop, this PC. Okay, problems. Let's try this other USB stick drive. I need to be able to see the USB stick so I can see this data. Let's try one last time. Okay, there's my USB sticks now, and there's my data files. And I'll start off with a 10 gigahertz magnitude, and the standard deviation is what you want to compare to the spec. So in this CSV file, there's a whole bunch of header information, and then this is the frequency at 10 gigahertz, and this is the S21 linear. It says it's linear. You want to take the standard deviation of this column, so I'll say standard deviation of this data. is 201 points. But this is linear format, so to convert it to log, it's 20 times log of 1 plus this value. And now that's 0.001626. This is dB. This is the number you want to compare to this 0.004. And you can see it's less than that, so that meets the spec. I mean, this is a quick verification again. For the phase, let's bring up the phase data. Here, there's no conversion from linear to log, it's just linear, so it's the standard deviation of this row, and I think it goes to row 224, I believe. So you would take this number, 0.08, this is in degrees. This you would be comparing it to 0.018 degrees to this 0.07, and again, it's less than that. Let's look in the higher frequency. We'll look at 22 gigahertz magnitude. We don't have to look at the phase here. So this is linear, so again, I'm going to take the standard deviation of this through here. It's going through 224. Then I take 20 times log of 1 plus this value. I could type in Excel. Okay, let me start again. It's 20 times log of 1 plus this cell. That's 0.006, 0.007, and that's right around the value that we made there. So it's still less than the 0.07 dB. Just to double check it, we can look at the phase also. 22 gigahertz phase. We say standard deviation of this through here, and I'll change this to 224. .045 degrees, and that's less than 0.14 degrees. So that's how you would make this measurement for trace noise. So to summarize again, let me put these away. You make a direct connection between your ports. Your box has to be warm up. You make a direct connection between your two ports. A short cable is good, a nice solid cable, a good phase stable cable. And you set the power to high, the IF bandwidth to 300 hertz. You do a CW frequency. You can spot check a few frequencies. You save the linear data and the phase data. You do a standard deviation. And then if it's the linear, you convert it to log, and you compare it to these values.